Okay, now as far as I'm concerned, the material that we cover in this video is the hardest material on the Leave Insert Higher Level Algebra section. So let's have a look at this first question here. We could be asked to find k if x plus 2 is a factor of this cubic. So in this case, as we go through this video, we're going to have cubics, but we're going to have unknowns. In this case, we have x cubed plus 6x squared plus kx plus 6 equals 0. Now, there are two different ways of doing this. One of them is really straightforward and one of them is a little bit harder, but we need to do it both ways as we move through this material. So in the first example here, it tells me that x plus 2 is a factor of this cubic. That tells me two things. If x plus 2 is a factor, I know that I can divide x plus 2 into this cubic and my remainder will be equal to 0. That's the harder way of doing it, but it's the way that we need to learn. The alternative is realizing that if you know the factor, you can convert it into a root. If x plus 2 is a factor, in order to find the corresponding root, we simply isolate x. We could say that x equals minus 2 is a root. And now all we need to do is sub the root in, and I know that if I sub in the root, the whole thing equals 0. So let's have a look at that first. It's the easy way of doing this question. If I need to find the value of k, and I know that x plus 2 is a factor, I can convert x plus 2 into its corresponding root, and I can now just sub it in. So I can say that minus 2 cubed plus 6 times minus 2 squared plus k times minus 2 plus 6 equals 0. And I know that this is true because I know that x equals minus 2 is in fact a root. Now I've got one equation and one unknown, so I can find the value of k. Minus by minus by minus gives me minus, so I get minus 8. Here there's two minuses, so it's going to be plus 24 minus 2k plus 6 equals 0. 24 and 6 is 30, minus 8 gives me 22. So I have 22 minus 2k equals 0. If I add 2k to both sides, I would get 22 equals 2k. And I could then divide both sides by 2 and get my value for k as 11. Okay, so that's very straightforward, and if this question came up in the leave insert, that's the way that you should do it. That's by far the easier way of doing it. However, let's have a look at the other way of doing it, because there are questions where you won't be able to do it like this. So if x plus 2 is a factor of this cubic, the other thing we could do is I can use long division to divide x plus 2 into the cubic. And the remainder, if you divide a factor in, you know the remainder is 0. Whereas in actual fact, when I get a remainder this time, it's going to be something like 10k plus 12, or it's going to be in terms of k, and then whatever my remainder is, I can let it equal to 0. So let's just do this example again, but a different way. Okay, so if I know that x plus 2 is a factor of this cubic, the other thing I can do is simply divide x plus 2 into the cubic, and I know that the remainder will be equal to 0. So I want you to just think of this purely as junior cert long division. It's the exact same other than the fact that there's a k here. Nonetheless, we're going to follow the same steps as we've always been following. The first thing we'll do is divide x into x cubed. And x divided into x cubed will give me x squared. The second thing I'm going to do is multiply. I'm going to multiply x squared by each of these terms. X squared by x is x cubed, while x squared by plus 2 is plus 2x squared. My third step is to change my signs and subtract, so this becomes a minus and this becomes a minus. Now I want to point something out to you here. When we do our subtraction line, it's as if we're splitting this in two. We view just the x cubes together and then the x squareds together. The x cubes cancel each other out, and then the x squareds, we have 6x squared minus 2x squared, which gives me 4x squared. So in fact what we're getting is, it's like we're getting 0 from these two, but then this gives me a 4x squared. I just want to point that out to you because it's going to come into play in the next example, which is far more difficult. Once we've done our subtract step, we're going to take down the next term. The next term in this case is plus k times x. We're going to start our process all over again. We're going to divide the first thing here into the first thing here. X into 4x squared gives me plus 4x. Now we multiply the thing we put up here by both of these. 4x by x is 4x squared, while 4x by 2 gives me plus 8x. The third step is to subtract, so I'm going to change my signs and I'm going to subtract. Notice once again that I'm grouping the x squareds together and the x's together. I'm going to say that 4x squared and 4x squared cancel each other out. When I'm worrying about these, I'm completely ignoring the terms that have x's in them. And now I'm worried about the kx minus 8x. I'm completely ignoring the x squareds. This is the first step that is different from junior cert, because there's a constant here. When you get to this stage, you should always use rough work. On the top, I have k times x, and on the bottom, I have minus 8 times x. What you want to do is factorize out your x, and write this as one term. If I factorize out my x, I can write this as k minus 8 times x. If you get into a habit of just whenever you have a variable like that, you write it in your rough work and you factorize out your x, it's going to make these questions so much easier. So kx minus 8x can be written as k minus 8 times x. And that's my third step. And then I'm going to do my fourth step, which is to take down the next term, which is a plus 6. And now I'm just going to start my process all over again. I'm going to divide the first thing here into the first thing here. X divided into k minus 8 times x. Well, the x will divide into itself, and I'd just be left with k minus 8. The second thing we're going to do is multiply. We're going to multiply k minus 8 by x plus 2. K minus 8 by x simply gives me k minus 8 times x. Well, k minus 8 times 2, I can write this as 2 times k minus 8. I think it's easier to just have the 2 in front of the bracket rather than the other way around, but it doesn't really matter. My third step in long division is to subtract. So what I'm going to do is change my signs and subtract. So I put a minus in front of this term and a minus in front of this term. So the reason I wanted you to write kx minus 8x as one term is so that when you got to this stage, you just have to change one sign. You literally just stick a minus in front of the bracket. You've only one term, so you only have to change one sign. Once again, I want you to notice that it's as if we're splitting our page in two. We view the terms with the x's together and the constants at the end together. K minus 8x minus k minus 8x will cancel out. And here I have a 6 on the top, minus 2 times k minus 8. Now, so that's my remainder. So I've divided x plus 2 into this cubic, and my remainder is 6 minus 2 times k minus 8. However, this question has told me that x plus 2 is a factor of the cubic. If you divide a factor into a cubic, your remainder is 0. So I know that my remainder, that this must be equal to 0. So now what I'm going to do is wipe this off. I'm going to take my remainder, let it equal to 0, and solve and find a value for k. So from there it's relatively straightforward. I let my remainder equal to 0, and I have a basic enough equation that I solve, and I ended up with k is equal to 11. So we've done that by two different methods, and clearly if this came up in an exam, you would use the first method. You would simply convert your factor into a root and sub it in, and it's way easier. However, as you're going to see in the next example we do, sometimes it's unavoidable for us to carry out the long division in this fashion. Okay, so let's have a look at this kind of question now. In this question we're told that x squared plus ax plus b is a factor of the polynomial x cubed plus qx squared plus rx plus s equals 0. With that in mind, we could be asked to prove that r minus b is equal to a times q minus a, and s is equal to b times q minus a. So clearly this is far more involved than example 1. But there's only one piece of information that's been given. I've been told that this is a factor of the cubic. If this quadratic is a factor of this cubic, that means when I divide it in, it will be equal to 0. When I divide it in, the remainder has to be equal to 0. So when I divide x squared plus ax plus b into this cubic, my remainder is going to look something like this. I'll be able to let them equal to 0, and I'll relatively easily be able to get to here. In a question like this, you should essentially completely ignore what you're being asked to prove until you've carried out your long division. So I'm going to wipe this off. We'll bear it in mind, but for the moment, it's not really relevant. That's what I need to prove, but in order to prove it, I first need to carry out a very difficult long division question. I know that this quadratic is a factor of this cubic, so when I divide it in, my remainder will be equal to 0. And that's all that's relevant for the first half of this question. So I'm going to divide my quadratic into my cubic. And I'm going to follow the same steps as we've been following since third year, we're going to do divide, multiply, subtract, and then next term. So let's just go through this one. The first thing we need to do is divide the first thing here into the first thing here. X squared divided into x cubed is going to go x times. Now I need to multiply. I'm going to multiply x by these three terms. So x by x squared gives me x cubed. X by ax is going to give me plus ax squared. And x times b is going to give me plus bx. The third step in long division is to subtract. So I'm going to change the signs. This becomes a minus, this becomes a minus, and this becomes a minus. Once again, I want you to notice that first of all, I'm only concerned with my x cubes. I'm completely ignoring everything else. The x cubes will cancel. Now I'm only concerned with my x squareds. I completely ignore everything else and I'm only concerned with my x squareds. This is where we need rough work. We have a qx squared on the top minus ax squared on the bottom. So I would write that out in my rough work. Qx squared minus ax squared. I want to factorize out the x squared so I can write this as one term. So I'm going to write this as q minus a times x squared. Qx squared minus ax squared. The way that I want to write that down here is as one term. Q minus a times x squared. I have to do the same thing now with my x's. I'm now completely ignoring everything else and I'm only concerned with my x's. On the top I have rx and on the bottom I have minus bx. So again, I want to write that as one term. Rx minus bx. If I factorize out my x, I'm left with or minus b times x. So I can just write this one as plus and then a bracket or minus b times x. That's my third step, and now I need to look at the fourth step. The fourth step in long division is to take down the next term, which in this case is just a plus s. And I'm going to start my process all over again. If I start my process all over again, my first step is to divide. So I'm going to divide x squared into the first thing here. X squared divided into q minus a times x squared. The x squared goes into itself and I'm left with q minus a. And the second step is to multiply. I need to multiply q minus a by these three terms. This is the stage that students are most likely to make a mistake. If you're multiplying q minus a by these three terms, don't do any work. Just literally just list it out. So I'm not going to multiply anything out here. I'm just going to list things beside each other. Q minus a times x squared. I'm just going to write that as q minus a times x squared. I'm not going to bother multiplying it out. Q minus a times the second term, ax. I'm not going to bother multiplying it. I'm simply going to write it as q minus a times ax. Now to give myself a bit more space, I'm going to wipe out what I've written on the right hand side column. Now, so I need to multiply q minus a by the third thing here, which is a b. But once again, not going to bother actually multiplying it out. I'm simply going to write it as plus b times q minus a. So I want you to notice on that line that I haven't actually done anything. I've just got q minus a and multiplied it by all three terms. Q minus a by the first one, q minus a by the second one, q minus a by the third one. If anything, that's the easiest step because I didn't do anything. I was just listing letters beside each other. The third step in long division is to subtract. Now, you need to really pay attention here. I'm going to change the sign in front of the term with the x squared, change the sign in front of the term with the x, and change the sign in front of the term at the end. Remember, we have to split these into, we're just viewing them separately. First of all, we're going to view our x squareds. Q minus a times x squared minus the same thing will cancel out. Now we're only going to look at the x's. I'm only concerned now with the x's. I have or minus b times x on the top, and I've minus times q minus a times ax on the bottom. I don't care about the rest of it. I'm only concerned with the terms that have an x in it. So I'm going to get or minus b times x minus q minus a times ax. We're going to view that as our first remainder. And then the third thing we have to look at are the constants. The constants on the top I have an s, and on the bottom I have minus b times q minus a. We have to view these as two completely separate remainders. Think about, if you were doing long division with actual numbers, everything would cancel at this stage. You would have something like, imagine you had a 12x on the top. If you had a 12x on the top, you would have a minus 12x on the bottom and you'd cancel out your x's. So I have to view this as if one of them minus the other one will cancel out. It'll be like having 12 minus 12, they'd cancel out. So the coefficients of x are one remainder, the constants at the end are another remainder. And at the start of this question, I was told that x squared plus ax plus b is a factor of the cubic. If it is a factor of the cubic, that means the remainder is 0. In this case, I have two separate remainders. I know that the number in front of x on the top and the number in front of x on the bottom would cancel each other out. I'd have something like 12 minus 12. Now, we don't actually need to concern ourselves with the x's at all. If you just visualize normal long division, if you had 12x minus 12x, I don't actually need the x's. If 12x minus 12x equals 0, I can still just say that 12 minus 12 equals 0. So in fact, I can just ignore the x's. The x's aren't relevant. I know that the coefficient of x on the top and the coefficient of x on the bottom add up to 0. I know that all I need to take is the coefficient of x on the top, the coefficient of x on the bottom. I know that they would be equal to 0. Because the original thing that I divided in is a factor, means the coefficients add up to 0. You don't actually even need the first line there. You could have went straight to this line if you wanted. I'm just explaining it for the first time we do it. That's my first remainder. If I was doing long division, I'd always have something at the end, like maybe 8 minus 8 or 10 minus 10. Basically, the number on the top and the number on the bottom add up to 0. So I can also say that this remainder, the constants that were at the end, are equal to 0. I can say that s minus b times q minus a equals 0. So now, I'm going to wipe off the original question and I'm going to write down what we were asked to prove. So I wiped it off just to have a bit more space in the question, but we were told that this quadratic is a factor of this cubic, and we were asked to prove that or minus b is equal to a times q minus a, and s is equal to b times q minus a. That made absolutely no sense whatsoever when given the question. However, once I've done my long division, this makes perfect sense. I'm basically already at my answer. Look at the second thing I was asked to prove, that s is equal to b times q minus a. I can clearly see that my second remainder here I'll get there in one step. All I want to do is take this term and move it to the other side. Or in other words, if I move to the other side, I'd have a plus b times q minus a. So I could just move my term across and I'd have s is equal to b times q minus a. And that's one of the things I was asked to prove. Same logic could be followed for the other remainder. I needed to prove that or minus b is equal to a times q minus a. Essentially, I just need to isolate the term with the or minus b in it. If I simply added a times q minus a to both sides, I end up with the other thing that I was asked to prove. Often it can be quite tricky after the long division, but for the most part, if you get the long division right, that's the tricky part. So I'm going to give you a number of questions now related to this type of long division, and I want you to see how you get on. Okay, so I'm going to give you 4 questions to practice this material. 3 of them are here, and there's one more on the next slide. In the first question here, we have x minus 2 is a factor of this cubic, and we're asked to find the value of k. Now, there are 2 different ways of doing this. First of all, you have a factor x minus 2, you could turn that into a root and you could sub it in and find the value of k. That's in the leave insert, that's the way I would suggest you do it because it's an easier method for this one. However, I also want you to practice doing this by long division and you should end up with the same answer. Because if you practice this easy one by long division, it'll make the next more difficult long division questions, at least you'll have practiced and it'll be more straightforward for you. When you divide x minus 2 into this cubic, you can let your remainder equal to 0, and then you'll be able to find the value of k. Question 2, we have x squared minus 2tx plus t squared is a factor of this. Now, I want you to notice that this is an x cubed, and then there's no x squared, and then there's an x, and then there's a constant. You've been asked to prove that p equals minus t squared and c equals 2t cubed. In order to do that, you're going to have to divide this factor into this cubic. However, you cannot carry out long division if there's no x squared term in the cubic. Remember from junior cert, when you're doing long division, if you have an x cubed, the next term has to be an x squared. Then the next term has to be an x, the next term has to be a constant. So you need to add in 0x squared in order to carry out your long division there. In question 3, we have x squared minus px plus q is a factor of this cubic, And with that in mind, we're asked to show that q is equal to minus 2p squared and r is equal to minus 8p cubed. So I want you to pause the video and take these down, try them yourself, and then there's one more on the next page. When you've done question 1 to 4, compare it to my solutions. Question 4 is by far the most difficult of the 4 questions I'm giving you. In this one, you have x squared minus px plus 1 is a factor of the cubic. With that now, it's telling you that a is not equal to 0, just because if a was 0, then this wouldn't actually be a cubic, it would just be bx plus c. So just so that the question makes sense, I have to indicate to you that a can't be equal to 0. Now, if this is a factor of this, I can divide it in and my remainder will be equal to 0. Using that information, you should be able to show that c squared is equal to a times a minus b. So I want you to give it a good bit of time to try these 4 questions, and once you've attempted them, then compare it to my solutions. Okay, so in question 1, we were told that x minus 2 is a factor of this cubic, and we were asked to find the value of k. Now there's 2 ways of doing this, and this is obviously the simple way of doing it. The simple way of doing it is realizing that if you know a factor of a cubic, you can find the corresponding root. If x minus 2 is a factor, then x equals plus 2 is a root. And if you know one of the roots, you can simply sub it in. If I sub in x equals 2, if I just rewrite this, except everywhere there's an x, I sub in a 2, I get one equation and one unknown, which allows me to find the value of k. And when I work through the question, k works out as minus 13. However, as you've seen from the examples, we often need to use long division with an unknown in it. So I'm going to now do this question again another way. I'm going to use the factor x minus 2. If x minus 2 is a factor, I can use a long division to divide it in. And I know that whatever my remainder is, it will be equal to 0. So let's have a look at that. And hopefully when we do long division, we'll end up with the same answer. We'll get k equals minus 13. Okay, so let's divide the factor into the cubic and see what happens. As always, we're following the 4 steps for long division. The first thing we do is divide. You can divide x into 2x cubed, and x into 2x cubed goes 2x squared times. Now you're going to multiply. 2x squared multiplied by x gives me 2x cubed. 2x squared multiplied by minus 2 gives me minus 4x squared. And the third step is to subtract. So this is going to become a minus 2x cubed, while this is going to become a plus 4x squared. And in that case now, again, remember that we're just grouping the x cubes together and the x squareds together. 2x cubed minus 2x cubed will cancel. 1x squared plus 4x squared will give me 5x squared. Now I'm going to follow the 4th step, which is to take down the next term, which in this scenario is just k times x. And I'm going to start my process all over again by dividing. I'm going to divide x into 5x squared, and that will give me plus 5x. I'm then going to multiply 5x by each of these. 5x by x is 5x squared. 5x by minus 2 gives me minus 10x. My third step is to subtract. So this is going to become a minus 5x squared, and this is going to become a plus 10x. Now again, remember, we're just grouping the x squareds together and then the x's together. The x squareds will cancel each other out, and this is the first point where it's a little bit different. I have a kx on the top and a plus 10x on the bottom. So I'm going to write that in my rough work. Kx plus 10x. I want to factorize out the x and write this as just one term. If I factorize out x, I'm left with k plus 10 times x. So kx plus 10x, the easiest way for me to write that is just k plus 10 times x. I'm now going to take down the next term, so the next term in this case is a plus 6. And I'm going to start my process all over again with my divide step. I'm going to divide x into k plus 10 times x. X divided into this term, the x divides into itself, and I'm left with k plus 10. My second step is to multiply. So I'm going to multiply k plus 10 by each of these. So k plus 10 times x is simply k plus 10x. And k plus 10 times minus 2, I'm going to write that as minus 2 times k plus 10. I think it's just a lot easier there if you put the 2 in front of the bracket, although it doesn't really matter. And now what I want to do is I want to change my signs and subtract. So I'm going to draw a line underneath this, put a minus in front of the term with the x, and I'm going to put a plus in front of the second term. Once again, we're just grouping the x's together and then the constants together. So I have k plus 10 times x, and then minus the exact same thing, so the x terms will cancel out. And all I'm left with are my constants. On the top I have a 6, and on the bottom I have plus 2 times k plus 10. There's no more terms to take down, so that's my remainder. So x minus 2 is a factor of the cubic, which means that when I use long division, my remainder must be equal to 0. So what I'm going to do now is I'm just going to take this remainder, let it equal to 0, and find the value of k. So the last section in this question is quite easy. I let my remainder equal to 0, and I simply solve, and I worked out that k was equal to minus 13. Same answer as I got by subbing in the root. So obviously, if this question came up in the leave insert, it's far easier to just convert your factor into root and sub it in. I want you to be aware that in the question, if it's worded like that, it doesn't matter which you do. You can do either one. Now, the only reason I wanted you to do that one was by long division was so that you could attempt the other 3 questions. So let's have a look now at question 2. In question 2 here, we were told that x squared minus 2tx plus t squared is a factor of this cubic. And we were asked to prove that p equals minus t squared and c equals 2t cubed. For the moment, what we're being asked to prove is completely, it seems to have no link to the question, and it's essentially irrelevant until we've carried out our long division. I know that we need to carry out long division here because if they tell me that this quadratic is a factor of this cubic, if I divide the quadratic into the cubic, I know the remainder will be 0. So when I get to my remainder, hopefully the things that I've been asked to prove will make sense. But for the moment, I'm more or less just going to ignore the thing I've been asked to prove, and I'm simply going to carry out long division. We carry out long division the same way as we did at Junior Cert following our 4 steps. This one was a bit of an exception because there's no x squared term in the cubic. You cannot carry out long division unless each term decreases by, the power of x decreases by 1 in each case. So you have an x cubed, an x squared, an x, and a number. So I've added in a 0x squared, which obviously has a value of 0, but at least it solves the problem of the power of x decreasing by 1 each time. Just be aware that also here, in the thing you're dividing in, that also has to decrease by a power of 1 each time. So I have an x squared, an x to the power of 1, and then there's no x's, so that one's fine. So I'm ready now, I can just carry out my long division. The first thing I'll do is divide x squared into x cubed, and that will give me x. Then I'll multiply x by x squared, gives me x to the power of 3. X by minus 2tx gives me minus 2tx squared. While x times t squared is going to give me t squared x. The third step in long division is to subtract. So I'm going to change this to a minus, I'm going to change this to a plus, and this one becomes a minus. Notice that we just completely look at our x cubes only, then our x squareds only, and then our x's only. First of all, if I just pay attention to the x cubes, I have 1x cubed minus 1x cubed, so they cancel. If I only pay attention to the x squareds, I have 0x squared plus 2tx squared, which gives me plus 2tx squared. Now, it's the x's that is the first time we're going to run into problems. We have 3px minus t squared x. These are not like terms, so my advice to you is always do this out in rough work. 3px minus t squared x, and in this case I'm going to factorize out my x so that I can write this as just one term. This is actually 3p minus t squared times x. So what I can write, if I want to write this as one term, you just put a plus in front of the bracket and write it as 3p minus t squared times x. The fourth step in long division is to take down the next term. So I'm just going to take down my plus c, and now I'm ready to start the process all over again. The first thing I'm going to do is divide. You take the first thing here and divide it into the first thing here. X squared into 2tx squared. The x squared divides into itself, and I'm left with plus 2t. The second step is we're going to multiply. So we're going to multiply 2t by each of these terms. 2t by x squared gives me 2tx squared. 2t by minus 2tx gives me minus 4t squared x. Because plus 2 by minus 2 gives me minus 4, t by t gives me t squared, and then there's also an x here. Then finally, I'm going to multiply 2t by t squared, and in this case, it will give me plus 2t cubed. Now I'm going to change my signs and subtract. So my plus 2tx squared becomes minus, my minus 4t squared x becomes a plus, and plus 2t cubed becomes a minus. And now I'm just going to cross out. First of all, I'm just going to view my x squareds, then only my x's, and then only the constants at the end. If I view my x squareds, I have a 2tx squared on the top and a minus 2tx squared on the bottom, so they cancel. Be aware now, I have two separate remainders. First of all, the coefficients of x on the top and the bottom form a remainder. Then the constants at the end on the top and the bottom form another remainder. I'm going to wipe out what I have here in my rough work so that it's more clear. Let's look at the coefficient of x on the top is simply 3p minus t squared, while the coefficient of x on the bottom is plus 4t squared. If I was carrying out long division, if there was numbers involved here, we would usually have something like 10x on the top minus 10x on the bottom. So I'm basically just saying that the 10 minus 10 gives me 0. I know that whatever's in front of x on the top and whatever's in front of x on the bottom, they add up to 0. So my first remainder is that the coefficients of x are just equal to 0. The top and the bottom, if I added them together, they'd give me 0. The second one that I'm dealing with is the constant on the top and the constant on the bottom. I know that if I was carrying out long division, this could look something like a plus 4 on the top and a minus 4 on the bottom. They just cancel each other out. I know that whatever's on the top and whatever's on the bottom that doesn't have an x will add up to 0. So now I have two remainders, and it's only at this stage when you've carried out your long division that you should look towards what you're actually being asked to do. The first thing I was asked to do is to prove that p is equal to minus t squared. In order to prove that p is equal to minus t squared, obviously I'm talking about this equation here. It's nothing to do with this one because this one doesn't have a p in it and it has a c instead. So I'm just going to manipulate this and hopefully be able to get to the stage where p is equal to minus t squared. In this case, I notice that I've got like terms. I have 1t squared plus 4t squared. Sorry, I have minus 1t squared plus 4t squared. Minus 1 plus 4 gives me plus 3t squared. And obviously my goal here is to isolate my p. So what I could do is I could subtract 3t squared from both sides, and I get 3p is equal to minus 3t squared. I can now divide both sides by 3, and I get what I was asked to prove in part 1, that p is equal to minus t squared. And that's my first answer. Now I'm going to pay attention to the second thing that I was asked to prove, which is that c is equal to 2t cubed. This one is very straightforward. I simply look at this and I try and isolate my c by adding 2t cubed to both sides, and that's my second one proven. So in a lot of cases, once you've done the long division, it's very, very easy to get to what you were asked to prove. But you're going to find that when we get to question 4, even after we've done the long division, it's still very hard to get to the thing that you were asked to prove. Let's have a look now at question 3. Okay, the third question here, we were told that this quadratic was a factor of this cubic. And we were asked to prove that q is equal to minus 2p squared and r is equal to minus 8p cubed. It's essentially exactly the same as question 2, but obviously it's worth our while practicing questions like this. If this quadratic is a factor of this cubic, I know that I can divide it in and my remainder will be equal to 0. Hopefully when I get to my remainder, whatever they're asking me for here, hopefully it'll make a bit more sense, because at the moment it looks just completely random asking me to prove these variables. So I'm going to follow the 4 steps for long division that we've been following all along. The first thing I'm going to do is divide the first thing here into the first thing here. X squared into x cubed is going to go x times. I'm now going to multiply x by these 3 terms. X times x squared will give me x cubed. X times minus px will give me minus px squared. And x times q is going to give me plus qx. I'm now going to subtract, which means I need to change my signs. So I get minus x cubed plus px squared minus qx. Now, as always, we just treat the x cubes, then just the x squareds, then just the x's. X cubed minus x cubed will cancel. 3px squared plus 1px squared, Don't need rough work here because these are like terms. 3p plus 1p will give me plus 4p x squared. Also here I've got 3qx minus 1qx. Once again, they're like terms, so it's straightforward enough. 3qx minus 1qx leaves me with plus 2qx. The fourth step in long division is to take down the next term, and in this case that's a plus or. Now we're going to start our process all over again. The first thing we're going to do is divide the first thing here into the first thing here. X squared into 4px squared. The x squared divides into itself and I'm simply left with 4p. I'm now going to multiply 4p by these three terms. 4p times x squared is going to give me 4px squared. 4p times minus px gives me minus 4p squared x. While 4p times q is going to leave me with plus 4pq. I'm now going to change my signs and subtract, which means I get a minus 4px squared, I get a plus 4p squared x, and I get a minus 4pq. Now I'm just going to look at the x squareds, then just the x's, and then just the constants at the end. And if I look at the x squareds, I've got 4px squared minus 4px squared, which obviously cancels each other out. Now, I would always advise students to literally divide your page in two here. The coefficient of x on the top and the coefficient of x on the bottom have to add up to 0. The coefficient of x on the top is 2q. The coefficient of x on the bottom is plus 4p squared. I know that 2q plus 4p squared must be equal to 0, because I know that my remainder has to be 0 because the quadratic is a factor of the cubic. I now look at the constant on the top is or, while the constant on the bottom is minus 4pq. I know that the constant on the top and the constant on the bottom are going to cancel each other out and they must be equal to 0. So now that I'm at this stage, now that I've got my remainders, I need to look at what I've been asked to prove. The first thing I was asked to prove is that q is equal to minus 2p squared. It's clearly nothing to do with this one. This one has an or. It must be this one because this one only has q's and p's in it. In order to get to q equals minus 2p squared, my goal here is going to be to isolate my q. So the first thing I would do is subtract 4p squared from both sides, and I would get 2q is equal to minus 4p squared. In order to get to isolate q completely, I need to divide both sides by 2. And I will get q is equal to minus 2p squared. And that's what I was being asked to prove, so I'm happy out leaving that one as q is equal to minus 2p squared. Now let's look at the second one. Is asking me to prove that or is equal to minus 8p cubed. So first of all, I obviously want to isolate my or. So if I isolate or here, I get or is equal to 4pq. But there's an obvious problem in this one, in that what I'm trying to get to only has or's and p's in it. Whereas what I have at the moment is or, it has a p, but it also has a q. So I need to use substitution to get rid of my q. From what I'm after proving previously, I know that instead of a q, I can sub in minus 2p squared. So I'm just going to sub in, instead of q, I'm going to sub this in. I'm going to say that or is equal to 4p, and instead of a q, I'm going to sub in this guy. So it's actually 4p times minus 2p squared. And if I multiply that out now, 4 multiplied by minus 2 gives me minus 8. P multiplied by p squared gives me p cubed. So I'm left with or is equal to minus 8p cubed, which is exactly what I was looking for. Okay, the fourth question and the last one we're going to look at in this video is, we're given a quadratic which is a factor of a cubic, and this time we need to show that c squared is equal to a times a minus b. So it's the exact same as the previous questions. Once again, you should notice in your cubic that there was no x squared term. So you have to add in a 0x squared when you're writing out your long division. The first thing that we're going to do is divide x squared into ax cubed, and that's going to give me ax. The second thing I'm going to do is multiply ax by these three terms. Ax multiplied by x squared gives me ax cubed. Ax multiplied by minus px gives me minus apx squared. While ax multiplied by 1 simply gives me a times x. Now I'm going to change my signs and subtract, which means that this becomes a minus ax cubed, this becomes a plus apx squared, well this becomes a minus ax. I'm now just going to look at my x cubes, then my x squareds, and then my x's. With the cubes, I've got ax cubed minus ax cubed, so clearly they cancel out. With the x squareds, I have a 0x squared plus apx squared. So in this case, the 0x squared is more or less irrelevant. I simply have apx squared. For the x's, I don't have like terms, so I need to do this in my rough work. I have bx minus ax. So just like in all the other examples, I want to factorize out my x. If I factorize out my x, I'm left with b minus a times x. So I can simply just take this one down and put a plus in front of it and write it as b minus a times x. And the fourth step that we need to do is we simply take down the next term, which is a plus c. Once again, just for the sake of having a bit more space, I'm going to wipe out my steps here. And now I just start my process all over again. The first thing I need to do is divide. So I'm going to divide x squared into apx squared. X squared divides into itself and I'm simply left with ap. I'm now going to multiply ap by these three terms. ap times x squared gives me apx squared. ap times minus px, in that case plus by minus gives me minus. I have an a, I have p multiplied by p, which is going to be p squared, and I also have an x, so it's going to be x. So ap multiplied by minus px is minus a p squared x. And then I have ap multiplied by 1, which in this case is just going to give me ap. The third step in long division is to subtract, so I'm going to draw a line underneath them and I'm going to change all my signs. My plus apx squared becomes minus apx squared. My minus ap squared x becomes plus ap squared x, and plus ap becomes minus ap. And as always, we're going to just look at the x squareds, then look at the x's, and then look at the constants. With the x squareds, I have apx squared minus apx squared, so they're going to cancel. And the next two that I'm going to look at are my two separate remainders. I know that the remainders in this case are going to be equal to 0, because I know the original quadratic is a factor of the cubic. So the coefficient of x on the top is simply b minus a, while the coefficient of x on the bottom is plus ap squared. I know that the coefficient of x on the top and the coefficient of x on the bottom need to cancel each other out, or in other words, they must add up to 0. The constant on the top is a c, while the constant on the bottom is minus ap. And once again, I know that the constants need to cancel each other out, so they must also be equal to 0. So now I have two separate equations. However, this one, and this is way that it's likely to come up, and this one is far more difficult. The reason this is far more difficult is because what I've been asked to prove is that c squared is equal to a times a minus b. If you look at what we've been asked to prove, that equation has c's, a's, and b's in it. Neither of my remainders have only c's, a's, and b's. This one has a c and an a and a p. This one has an a and a b and a p. So this poses a serious problem. Neither of my remainders have the right letters. So the only way to do this is by substitution. I want to get rid of the p in both of them. So what I need to do is, in one of these equations, I need to get p on its own. And then I need to sub that into the other one. I think it's probably easier here if we take the simpler equation and isolate our p. And then when we have isolated our p, we can sub it into the other one. It doesn't actually matter which one you do, but it's going to be much harder to isolate p here than it would be to isolate p here. What I'm going to do now is I'm going to wipe this off the board, and we're just going to start with these two equations and see what we can do in order to get to c squared equals a times a minus b. So I'm trying to prove that c squared is equal to a times a minus b. At the moment, the problem is I've got two equations, neither of which have a, b, and c in it, both of which have p in it. So I need to get rid of my p. And in order to do that, I have to take one of my equations and isolate p. It's probably easier if we isolate p from the simple equation. So what I would do first is I would add ap to both sides, and I would get c is equal to ap. In order to get p on its own, I would divide both sides by a, and deduce that P is equal to C divided by A. And now I'm in a good place. Now I know I can rewrite this equation, except everywhere there's a P, I can sub in C over A. So I'm just going to rewrite my equation here. I have B minus A, and I don't really need those brackets. They were only there as part of the long division. And now I have plus A, but instead of A times P squared, it's going to be A times this. I know that P is actually C over A to be squared. So now I'm in a good place. I have an equation with A, B, and C in it, which is ultimately what I'm trying to get to. If I haven't made a mistake, I should be able to just manipulate this around and end up with what I've been asked for. So what I would suggest now is just ignore this for the moment and just simplify it as much as possible. For me, the first thing I should do there is to get rid of the squared, or at least square the fraction. So I can write this as B minus A plus A times, and if you're squaring a fraction, you just square the top and square the bottom. So C by C becomes C squared and A by A becomes A squared. Now, it doesn't actually matter. I'm just going to show you the way that I would do this question. If you have A times C squared over A squared, you could view this as A over 1. You just multiply the tops by each other and multiply the bottoms by each other. A times C squared over A squared can simply be written as AC squared over A squared. Just, it's tidier if I write it like that. And now you should recognize that you've got A by A on the bottom and you have an A on the top. So one of the A's on the bottom will cancel with the A on the top, and in fact that fraction simplifies simply to C squared over A. Now I would ask myself, what is the immediate complication? The immediate complication here is the fraction. In order to eliminate the fraction, I need to multiply by A. If I multiply everything by A, at least the fraction will be gone. So A times B is just AB, and minus A times A is simply minus A squared. And C squared over A multiplied by A just gives me C squared. Now I've simplified it down and there's no more obvious complications. So it's only at this point that I would draw my attention to what I'm being asked to prove. I need to prove that C squared is equal to A times A minus B. So obviously my goal now needs to be to try and isolate my C squared. So I'm going to start this at the top up here so that it's nice and clear. I'm going to try and get C squared on its own on the left, which means that I'm going to need to add A squared to both sides and I'll get a plus A squared on the right. I need to subtract AB from both sides and I'm going to get a minus AB on the right. And now I'm almost at my answer. I simply need to factorize out my A. If I factorize out A on the right hand side, A into A squared goes A times, A into minus AB goes minus B times. And I'm left with what I was asked to prove, that C squared is equal to A times A minus B. Now if you get a long division question, I think the chances are, if you get your long division right, it'll be very easy to get to the actual answer, what you were asked to prove. However, if you get a difficult one, it's likely to be in this form, where you have two equations, but you have the wrong letters in your equations. And you have to isolate a letter in one of the equations and sub it into the other one. You'll probably find a good few examples of that in your books or in whatever resource you're using. I think it's really, really important that you're clear on what we've done in this video. As I said at the start, I think this is probably the hardest thing that comes up in algebra, so it's worth your while to do a good bit of practice on these ones.